In this video, I will be explaining a basic concept in thermodynamics, which is nothing but the concept of work in thermodynamics. So let us first understand what is the concept of work in Newtonian or classical mechanics. So let us say that we have a block of mass m on this floor, and initially it is at rest position, and its coordinates with respect to origin is 0. And let us assume that this block of mass m over here, it is subjected to a force F, and after few seconds this block is getting displaced by some amount of distance. So we in mechanics, the definition of work done by this external force on this block is given by the dot product of force vector and displacement vector. So in this case we can see that the force vector force is acting along the direction of displacement. So angle between the force and displacement vector is 0. So this formula, by applying this in this formula, we get magnitude of F into magnitude of S times cos theta. Since the direction of F is along S, the angle between these two vectors is 0. So we will get cos 0 over here. So cos 0 is 1. This work done is going to be force, magnitude of force F and magnitude of this displacement. This magnitude of force F is just F, and the magnitude of displacement over here is the final displacement minus this initial displacement. Since the initial displacement is 0 with respect to origin, the work done by the external force on this block is going to be F times x final. This is our concept of work in Newtonian mechanics. This is the concept of work in classical or Newtonian mechanics. But when you come to thermodynamics, work definition of work is something different. So let us assume this schematic over here. In this schematic, there is a battery and there is a circuit connected with this. In this circuit, we have a switch over here and a resistor that is connected. So I am going to consider this battery as my system. This is my thermodynamic system, battery. So by the concept of thermodynamics, everything external to this battery is my surrounding. Since the battery is my system, everything external to this is my surrounding. Now, when the circuit or the switch is closed, after some time the circuit is getting closed, so the battery is getting discharged. So there's some amount of current I that is going to flow over the circuit. So after some time, when this current is flowing, the battery is getting discharged, so its charge is going to get reduced, and this resistor, due to the heating effect, it is going to get hot. So I will ask a simple question here. We have considered in this schematic, we have considered this battery as my system and everything external to this battery as my surroundings. So my question is here is the battery or the system doing any external work on the surrounding? Now, to understand this problem much better, let us do some small modifications in the schematic or circuit. Now, I am going to consider the same battery over here and the same switch in the circuit setup, but the change which I am going to do is I am going to replace this resistor R over by a motor here, and along the motor in the shaft I am going to attach a string, and in the string mass of block M is attached. So repeat the same experiment which we performed here in this setup. So when we close the circuit, this is my battery over here. When we close the circuit, the current is going to flow here. Current is going to flow in the circuit, and instead of resistor, this motor is going to rotate. So when the motor is going to rotate, this block of mass m along with the string, it is going to move upwards. So in this case, the battery is also my system. The same consideration, this battery is going to my system, everything external to the battery is my surrounding. So in this case, you can clearly see that the surrounding, this block of mass m is displaced by some distance, it's moving upwards. So in this case, we can say that the battery is doing some external work on the surroundings. So from this experiment, I will explain the definition of work in thermodynamics and how do we say when a system has performed any external work on the surroundings. How to say. Now let's go to definition. In thermodynamics, work done by a system on its surroundings is defined as an interaction whose sole effect external to the system could be reduced to the rising of a mass through a distance. So let us understand this definition much deeper. What they are saying is, in thermodynamics, this system over here, whether we have to find out whether this battery has performed any external work to the surroundings. Now we can reduce this system where external to the system, I mean this block of mass m is external to the system, so reduced to the rising of a mass through a distance, this block of mass m is getting displaced. So this is the definition of work in thermodynamics. If anything external to the system, I mean if any surrounding could be reduced to the rising of mass m, any surrounding could be reduced to the activity of raising a mass of m, then we can say that the system has performed some external work on the surroundings. Thank you.